Hello everyone, welcome to my Notes on Notebooks using ArcGIS API for Python presentation. Quick introductions. My name is Matt Pawson. I am a GIS analyst here at New Plymouth District Council. I've been working here for the last 6 or 7 years, with the last 1.5 years being in the IT GIS team. You can see there on the left hand side there's a shortened link to the story map that I'm using during this presentation. So if you want to load that up in your browser and follow along, feel free to do so. So before we get into the two notebooks that I'll be talking about today, I'll just go over a couple of things. You do need admin rights to your portal that you're trying to access these through to be able to run these. And if you're using ArcGIS Pro as your notebook idle, then you'll need ArcGIS Pro 2.6 or higher. And yeah, bit of a disclaimer, I am a GIS guy doing some programming, not necessarily a programmer. There are probably much better ways to optimize this code, but if there are, I don't know them. So yeah, don't judge me too harshly. Right, so here at MPDC we have a somewhat comprehensive ArcGIS environment. So we use both Arc Online, an internal enterprise deployment, and an external enterprise deployment. And how we use our authoritative services that we register them on our ArcGIS enterprise environments as registered services, and then we consume those within our portals to create our web maps and apps. So today I'll first quickly go through a quick introduction on what actually the ArcGIS API for Python is. Then after that we'll talk about both my notebooks, the list of user notebooks, as well as the server dependency notebooks. I'll go into more detail on that later on, and then right at the end we've got some extra tips and tricks that I wanted to talk about, but I couldn't find anywhere to talk about within the notebooks themselves. So, what is the ArcGIS API for Python? Well, it's two things. It is both a Python library, in the same way that ArcPy is a Python library, as well as, and then it is also a API that translates between the Python script you're writing, translates that into RESTful requests to the ArcGIS server, which can then read those requests and post the results back to you. Why use the Python API over REST API then? Well, as you can see, you get to authenticate through your portal. The portal does all the heavy lifting as far as authentication goes. If you are querying your ArcGIS servers that are federated with your portal, then the portal still authenticates for you, and you don't have to do any of that yourself. On the right hand side here is essentially code that you would have to run using REST API versus Python API. So a lot more simple, as well as that the API for Python has been set up to better follow the flow of information within your portal environments. So in a similar way that ArcPy follows the same way you would do something, let's say an ArcPro, by you first loop through your project, then loop through your map, then maybe loop through your layers, and then get to your feature classes. The Python API does the same thing, but for the portal. So you first log into your portal, then you find the item or items that you're interested in, then you find the particular type of item, be it a feature collection or a web map. Then you go, let's say if you're doing a feature collection, then you can go into that and look at the layers. It's in a similar format to what you would usually click away at if you're doing this through a browser. Notebooks, ArcGIS notebooks are essentially rebranded Jupyter notebooks. These are cool things. You can run snippets of code in distinct instances. So essentially you can run a whole bunch of code beforehand and then run a particular cell right at the very end, and then just rerun that cell as you iterate through that to get the exact result that you need. Saves a lot of time just waiting around for code to run, because you don't need to run your whole script, you just run a cell at a time. But I've also got other cool things like these rich returns, which aren't particularly useful in these two notebooks, but can be very useful if you're actually looking to actually code out a web map or something like that. And you can convert back to a normal Python file using conversion tools if you want to, so no real reason not to use them. So yeah, we'll get into the first of our notebooks. This one here, get list of users notebook. I'm running this in ArcGIS Online. We have so this is a similar one to what you'd find in a lot of other examples online. However, I've gone through the extra step of not only getting the list of users, but also getting working out if the user has a ArcGIS Pro license and what the entitlements have been assigned to that user as well. This essentially loops through the portal that you've signed into, finds out all that user information and exports it as a CSV. So first things first, we bring in our libraries and we define our parameters. If you are new to Python API, make sure you bring in the library in the exact manner that it's shown here from ArcGIS.gis import GIS capitals. This is how everyone does it online in their example notebooks, and so it just makes life a lot easier trying to follow along with other people's scripts. Next thing we do is connect to our portal. This is a piece of code that I will copy and paste into pretty much every single one of my notebooks that I'm using. As you can see, it uses getPass, so your password isn't exposed, it's dotted out. And yeah, if you want to, you can get rid of everything in the middle of this, and that will log you into ArcGIS Online as an anonymous user. Maybe you don't have access to Arc Online or Arc Enterprise. This is one way, even though this notebook won't work, you can still query Arc Online items anonymously. Right, first bit of this is to find all the MPDC employees in our Arc Online portal. So we essentially use this search code here, which goes through and returns us all the users in the portal. Make sure you specify the maximum number of users to be higher than the actual number of users in your organization to make sure you get everyone. If you don't specify this, it only returns the first 10 users, so that's not very useful. So yeah, definitely need that bit in the middle. The rest of this is pretty much just getting rid of people that don't have an MPDC email address, as well as just formatting this last active variable that we end up bringing through. Now the interesting bit is this whole append thing going on here. For each user, it's just appending a list to another list, and it's getting all the user information. So you can create their username, their email, their full name, their role, and when they were last active. From that, we turn this list into a pandas data frame. For those of you that don't know, pandas is used often in the data science world. It essentially tabularizes your list. This becomes very useful later on, as you will see, but all we're doing here is just bringing in that list. We're giving it we're giving it some column headers, and you can see what it kind of looks like as it gets printed out down here. So next step is we find all the users that have pro licenses. This first bit of code up the top here returns a particular, very specific license object if you want to look at what other licenses are available, you can uncomment out this bit here, which returns you the different types of licenses registered with your environment. This next bit essentially returns all of the users that have that particular license assigned to them, which is very good. And then from there we can go through similar steps for each of the user in that user list, tell me what entitlements they have. For ArcGIS Pro licenses, these essentially end up being their extensions that they have assigned. From that, we go what we did before, we append it all into a list, and we turn it into a pandas data frame, giving it some column headers, and you can see here, this is the sort of information you end up outputting. Now that we have our two lists, both of them have the column username, so we can use a very easy pandas merge function to join these two lists together. I'm specifically doing a left join, so we end up with a list of all the MPDC users as well as their pro information if they had any. Export CSV, and this is what we end up getting. A nice little CSV doc that I've turned into a table in Excel. The user's username, email, full name, their role, when they were last active, if they have a pro license assigned to them, and then what entitlements they have. So you can see your network analyst entitlements, or your extension or your spatial analyst extension in here. Very useful if you're starting to run low on pro licenses and you just need to quickly work out, hey, this guy hasn't been logged on for a while, let's get rid of his one or something like that. Useful script. Next one is our service dependencies notebook. This is quite a bit more complex. This was something I've been trying to work out how to do for a while now, and I think I finally cracked it. Key thing to all of this is within the administration side of the server, there is, for each service registered to the server, there is what's called a manifest.json file. Within there is a whole bunch of useful information that ties particular layers in the service back to the source enterprise geodatabase and feature class that they reference. So, parameters again, not much have really changed other than that we are importing server as SVR. As I mentioned before, even though we are going to be doing a whole bunch of ArcGIS server stuff, we still authenticate through our portal, which is very useful because our servers are federated with our portal, so it still handles all the authentication. First thing we're doing here is just defining a function. We end up calling this later on, we're not running it at the moment, but essentially it takes in the server name and a folder, and then for that particular folder finds all the services in that folder, and then returns information about that service, including the service manifest JSON file. So that whole JSON file is being recorded as an element in the list. But a bit of a mouthful, but yeah, essentially we have JSON in Python. It's a bit crazy, but yeah. So this is the first bit that we actually run. For server so first of all, it finds the different services that are federated. So I'll start that again. It finds the different servers federated with the portal. It then finds all the folders for each one of those servers and just appends it all into a folder list. So we can see here we have two servers, one with 5 folders and one with 18 folders. This next bit has been running that function that we looked at earlier, which is essentially going through and finding for each of those servers. It is looking at each folder in that server, finding all of the services, and then getting the manifest JSON file for each one of those services We also run it just by itself up the top with these particular parameters. What that's doing is getting any of the services in the root folder. Best not forget about them. So now we've got a somewhat massive list with a bunch of JSON files in there. This next bit looks a bit complicated, but all it's really doing is just parsing out, loading in that JSON file and parsing out particular information that is recorded in it. A lot of the particular key pairs, the names of them don't really make sense, like this on-premise path doesn't really mean much to anyone, but what that actually is the path of the project or the MXD that was used to create that service. So that's very useful information. We've also got other things down here, like within the connection string you can find the enterprise geodatabase that the service was created from, as well as further down we're also getting our on server name, which is actually the layer name within the service. So it's doing a bunch of stuff, parsing a bunch of information out of the JSON file and appending it all into another list of lists. For this particular example, we had 158 services inputted. We had 13 services that did not have a manifest JSON file. These tend to be services like geoprocessing services that you wouldn't really expect to have any registered information against them. And then we have 692 layers within each service being outputted. We wrap all that up into a pandas data frame again and export it to a CSV, and we end up getting a nice little CSV containing a bunch of very useful information: server name, server folder, service name, if it's referenced or hosted, project path that was used to publish the service, the enterprise geodatabase that service sits in, the type of connection to that database, and then the actual feature class of that particular layer within the service. So in this screenshot here, all I've done is filtered this by the feature class name, and we can see that if we're making any changes to this particular water supply lateral feature class, that it would potentially impact any one of these services. Very useful information when you're trying to go through change control as far as identifying dependencies and making sure you have backup plans or testing these once you've made your changes. We tend to republish our services whenever we change anything to do with schemas on them, so very useful to work that out. So yeah, those are the two notebooks. I flicked me through an email. I've got my email at the end of this story map if you want to get hold of those from me. I'll quickly go through a couple of tips and tricks. These are things I wish I'd worked out a little earlier, but yeah, essentially for a lot of these objects you can encapsulate it in a list call, and that will just give you a bunch of things that you can query against it. So just type in me.username, that gives you your username, and you can kind of go through each of these different things and work out what specifically is useful for you. You can also encapsulate it in a help call, and that will give you a bunch of information about that particular object. What's also useful for identifying particular things you can query about that item or about a content item is going to ArcGIS Online Assistant. Give that a Google if you don't know what it is. Signing into that, and you can actually look at the item's JSON file from in here. Very useful to try to find particular things that you can query by, as shown in these examples here. And yeah, that's about it for me. Yeah, eventually I will probably do one or two things with this. Export it to a SQL table instead, so we can use it in more in some of our reporting tools that we have. The link to the story map is again down here at the bottom, and my email is also here. So if you want a copy of one of these notebooks, flick me through an email and I'll be happy to send it through to you. And yeah, that's about it for me. Thank you for paying attention, and I hope that was of use in some manner. Cool. Catch you later.